Hey, welcome to QConPlus. Today's title is Journey of Becoming a Better Developer. My name is Januar. I actually work for ING Bank, and currently my role is Head of Technology of ING Neo. I'm actually from Indonesia and Australia. I currently live in Singapore. So ING Neo that I work with is a business unit that works on various banking innovation activities. So in my current role, I work with various different startups that's funded by ING in various phases. I previously worked also in Asia as a head of engineering. Actually built the bank, a mobile-only bank in Philippines, and at the same time I built a team from scratch, from 0 to 300 people in a span of 2 years. But the primary focus of this talk is about my personal experience and my personal tips for all the engineers around the world. I started my career as ING in ING as a junior dev, and how I ended up being one of the head of engineering. So yeah, this is gonna be a lot of tips that I give to my individual contributors, but also managers that manages individual contributors. First of all, why is this talk though? It's such a generic topic, I would say. It seems random, becoming a better engineer and developer, but truly it's not. I can probably talk a bit about architecture, microservice, or security, or blockchain, but maybe that's another topic for another time. But I decided to give this talk because I think the answer is not so straightforward. If you look at the picture on a slide. There is some people who posted still this is an example from Hacker News a few days ago, about how to improve as a struggling junior SWE or software engineers. They posted there for, it's such a pity that people still ask, but it's also saying it says a lot about our industry, and the technology. A lot of people are sometimes not willing to ask. They want to stay anonymous, the imposter syndrome, things like that. But this is why I'm very passionate to actually help these people, especially my team. But hopefully my tips, can be useful to some of you that listens or tuned into this session. So first, before we actually get into the how, we need to get into what does it mean into becoming a better developer, before we jump into the how. For some people, it means more money or title, senior engineer, staff engineer, they want to become those people. They want to become the engineering manager, senior engineering manager. For some people, it's the company, they want to join the big tech, the big organization like the FANG organizations. For some people though, it's really about improving their skills regardless of those above. Getting experience, making bigger impact, solving harder problems. So this talk is really about, how do you becoming a better developer, not in terms of money, not in terms of title, but really about going deep into, what are the methods for me to actually improve my skill. And at the end, the journey of becoming a better developer is, it's about gaining more confidence in solving problems. It's about, gaining efficiencies in solving those problems. And also gaining, confidence in finding your way around in unfamiliar problems. So, because once you do that, I think at the end of the day, if you're good and you're improving and you're not stagnant, the money will come, the title will come, and the company will come. That's the truth. So this is not about shortcuts. You're not gonna find in this talk about how do I get a job in Google or how do I get a job in Facebook. You can actually look at the internet and go on YouTube. There's a lot of people actually talking about that. So funny. But this is really about you wanting to improve. Okay. So Before we actually get into the how, we need to define what is better. And for me, about being better is about having this understanding that there is this thing called competencies and consciousness. Okay, so when you learn certain skills, it's defined into various stages on these 4 different stages. I'll go very quickly. It's called unconscious incompetence at the start. You're not even aware of such skills. So let's say coding, you're not even aware of coding. And then you go into a stage where conscious incompetence. So you're aware of the skill, but you don't know how to do it. And then you got conscious competence. Now you know the skill, you've learned it, and then you have put an effort into it, and then you can actually do the skill, But then there is this final stage called unconscious competence, which is, to be honest, that's basically the mastery, right? And basically performing the skills becomes automatic. And this is where you want to be. You want to be a master. So let's take a look at a quick example. Let's say riding a bike. This baby over here doesn't know anything about bikes, doesn't know bike exists, doesn't even know the rule of riding a bike. And this young lady over here, she's at the conscious incompetent state because she's actually learning the skill. She knows there is a bike, there is a rule, and she's actually learning, but not yet proficient about riding the bike. And this gentleman here who's riding a bike to work, is at the conscious competence stage because he actually already rides a bike to school or to work. And you can actually, in this stage, is you're able to use a skill with effort. Now, the crazy part is the unconscious competence, which means riding a bike becomes an automatic for you. And you start doing things with bikes that you're not meant to be doing, such as playing in X Games and, nearly breaking your neck into, by riding a bike. And that's basically what I want to get people to understand, that there is competencies and consciousness. Having one skill doesn't mean that you're going to have it tomorrow straight away. You got to be patient because there is a cycle from being unconscious incompetence to being unconscious competence. And at ING, we basically apply how do we measure our people in terms of their skills. So we use what we call a Dreyfus model. Dreyfus is basically a person, a researcher, and then the model is actually being used a lot by military in the past. But quickly explaining what Dreyfus is there's different levels, such as from novice to masters, but then we measure them from 4 different areas, or what we call a mental function: the recollection, the recognitions, the decisions, and awareness. So what does it mean? So recollections is either you're situational or non-situational. So non-situational means like you don't even have a context. You don't even know the rule of the game. So like, for example, riding a bike, you don't even know the bike exists. That's non-situational. But then as soon as there is a rule, there's a, this is how coding works with compilers and interpreters, the fundamentals, then you become a bit more situationally aware in terms of recollections. You start understanding the rules of the game. And then as you go higher, such as you're being competent, you're starting to be measured on the recognition part. So does the person recognize certain patterns, understand the problem space, or is the person really just looking at the problem at one dimension? And we call that decompose. And for someone who's actually a bit more experts, they can take a look at the problems in a holistic view. And then we measure the decision making. Decision making actually done between by being analytical or being intuitive. So someone who's more senior or someone who's more an expert will always use most of the time make quick decisions confidently just like intuition. But for someone who's not that expert yet, they tend to be a bit more analytical. And the last but not least, which is quite difficult to explain, is the awareness, right? It's the awareness of the whole thing. That's where our masters or our really senior experts shines, because this is where for them things become automatic. We call that absorb. Absorb means, you and the systems are one, basically. And then the monitoring aspect, if you are still monitoring in terms of awareness, you start to see, you're not in the system, you're not absorbed in the system, you're not, the system and you is not one. So you still have a lot to improve to become a master. So that's the Dreyfus model. And a lot of people ask, like, how do I get from novice to master? And then this talk is really about that tips, right? So how do we get from novice to master? So I'm gonna give you guys a bit about, quick 5 tips. But the first one, one thing that I wanted you to remember, and it's really important, is experts are made, not born. Okay, so you have to remember this for your entire life. It's not because someone worked at Google and they're gifted by born. They're not selected from Google when they were born, or Facebook. Really, people are becoming an expert because they work really hard. There's no shortcuts. So tip number 1 is you gotta know your fundamentals. This is by perhaps the most important ones that you need to acquire. You need to know fundamentals. You need to know how to code, programming, especially if you get a chance to learn about C or C++, for example. You start to understand how to manage memory, how does compilers works and things like that. That actually helps you along the way, and complements your understanding about how does operating system works, networking, file systems. Why is it so important? You obviously can get a Python job by going into a Python bootcamp or a Java bootcamp, going straight into a Java job. But really, if you don't understand the operating systems, you're missing out on how this application get hosted. If you don't understand networking, you don't understand how application talks to each other. Maybe you're blindly using the libraries, but when you're troubleshooting network issues, you probably don't know, you don't understand. Most of the time, application works by writing into file systems, writing into database systems. So master your database systems of choice. Most of the time you'll use one of the RDBMS or a different data store. Learn about security or cryptography. These days, you're not going to make any useful apps or any useful systems without understanding how authentication, authorization works, and cryptography as well. How does compilers and interpreters works? Is it magic? You must be wondering how these things works. Learn about testings, learn about source control, version management. You're going to be working in a team, and I'm going to talk to you a bit about working in a team. How does build and package management work? So all of these are really important, and there's a lot of areas depending on how you try to specialize, but some of these fundamentals will go a long way. Personally, from me, I was lucky, went to a university that teaches some of the strong fundamentals about this. So when the industry change, you're not having your foot at the back that you only know Java. You can actually use these fundamentals to learn very quickly different paradigms or different technology, different concepts that the technology keeps evolving. So master your fundamentals. But how do you do that? So that's the second tip. Like, once you know what to improve, what you need to actually master in terms of fundamental, how do you really master it? And that's where I call deliberate practice. So if you look at this picture, This is an example that basketball players do, right? Player A and player B. Player A have 200 practice shots per hour. You know, colleague retrieve the shots, keep a record, and shots made, and shots missed, and errors. You know, you can see that player A is very methodical. You know, and keeps a better challenge than player B because 200 practice shots per hour. Okay, and basically, player B is doing it, you know, with less challenge, and you know it doesn't have any supports, and it just dribbles leisurely. You know, it's doing it with leisures, and then takes several breaks every now and then, right? So the point is this: the point of deliberate practice is about consistent, committed target. Keeps a record on how you perform it, and then you must set the goal as challenging, not just some easy problems. And then you want to repeat that until you get better and better. So, for example, from my side, I remember when I was back in my uni days, I finished uni, I used to do a lot of competitive programming practice every morning before I started working at ING. So 2 hours of my morning was, you know, reserved for solving puzzles, solving, you know, programming challenges, for a straight 6 months, and then every month I increase the difficulties or the amount of problems that you can solve within 2 hours, and then you realize at the end of 6 months you just got better at problem solving, and that's how you really, you know, master the fundamentals, and you can actually research it. Deliberate practice. A lot of athletes, a lot of mind athletes actually do that. If you're chess players, if you're, you know, it doesn't limit yourself just from physical athletes, but also, you know, mind athletes is also using deliberate practice quite a lot. And then tip 2.5, so still related to this, but you got to be able to believe in yourself. So what we call is, you know, you have to have a growth mindset, as opposed to fixed mindset. You know, growth mindset is believing that you can improve. You know, you know that, you know, hard work is actually the one that you need. People are not gifted, you know, you have to put your effort and attitude to get your abilities. And then you love challenges, so you know, you want to grow from that challenge. You like to try new things. And the opposite is also quite dangerous. If you have a fixed mindset, you'll never be improving because you're easily frustrated, and then you're just judging yourself in terms, you know, I'm not good at functional programming, so forget it. That's fixed mindset. So you want to be on the growth mindset. Tip number 3, surprise, surprise, this is all about health. I always say to my guys, to my team actually, the importance of sleep. You basically have, you got to understand how the brain works a bit, and you can research this. Sorry, I'm not a psychologist and I'm not a physiologist, but when you learn those skills in tip number 1 and 2, you know, your health also have to support you, and the brain works with cognitive processing, which means turning information into your skills, into your permanent memory. And then that's called cognitive processing. The problem with that is if you're not having enough sleep, your brain will have issues processing those skills into knowledge. So, for example, the stage of normal sleep cycle is divided into 2 most of the time. It's REM sleep or un-REM sleep, right? REM stands for rapid eye movement. This is where your brain activates, you know, when you're having dreams and all that stuff. But also what you didn't realize, during REM sleep, it turns the information into skills in the permanent memory. And then, of course, you can do a lot of research about it. And in fact, it is actually still, you know, professors and researchers are still actually trying to do a deeper research about understanding what's REM and NREM. But something that they found is, you know, if you miss your sleep, let's say you sleep for 5 hours instead of 8, you'll miss some cycles, and then that's where your brain starts to missing, you know, chances to turn skills into into your permanent memory skills. So if you're not getting a regular sleep and you're not getting woken up by your alarm bells, you feel like, gosh, I just want to sleep more, or you feel like you're sickly on Monday, you're having issues in terms of, forget about work, but also if you want to improve your skills, you need to get this under control. That's all I actually give in terms of physical tips to my team. It is actually proven that approximately 40% of your cognitive ability is reduced by sleep deprivation. So watch your sleep. Tip number 4, you need to know that software engineering is a team game. This is one of my favorite pictures when I spent a lot of time in Philippines. This is in our ING office. Picture was taken actually straight after our official sprint. We're not the big tech guys, but we definitely have each other's. These teams, ended up building the mobile-only bank and retail in Philippines in under 9 months. So that's a big achievement by this. But one thing for sure is it's not about one individual, it's about a team, right? So my tip to people is, be a team player, be a better team player. So remember, you have each other. If your team uses certain tools, learn about that team tools. Don't try to be egoistic in terms of, hey, I like this tool better, so I'm just going to use that tool. So learn about the team, learn about the tools, build the chemistry, because your success is defined by the team. It's not about your individual goals. And what I can say to a lot of young engineers and also senior engineers, managers, remember that you are actually working as a team. Your success is defined by a lot of people. Last but not least, in terms of on the last tip, is actually get a great coach, get a great manager. And I was lucky myself to be reporting to a lot of great managers, I would say. And why is that important? Because I think managers is one of the most important person beside your teammates in your career. So a great coach actually can give you insights on things that you might overlook. So for example, let's say you're not doing enough tests, or your coding style, you keep forgetting about the exception handling. So the person, or a great coach, it doesn't have to be a manager, by the way, it can be a senior person or a mentor. They can actually tell you if you forgot your fundamentals, execute the fundamental rights. So one person one day told me, hey Jen, I noticed that you haven't been writing your documentations. At some point in my career, one of my managers told me that. So, and that strikes me, like, okay, you're a senior guy, but sometimes you forget things in terms of fundamentals. So they can also be an extra motivator. It can spot your weaknesses, your areas to strength. What is your strength, what is your weaknesses? And I remember my manager told me, hey, well done, you have a keen eye for detail, for example, and that's your strength. So you have to keep the back of your mind, and it will tell you that this is your weakness, this is something that you need to work on. And classic example from the Hacker News story that I showed you was really simply, if you read that story, is that he doesn't have a manager. He doesn't get that feedback, not even from the seniors. And sometimes you feel like it is something wrong with me, but actually the answer is no. It's actually, you need to get a good coach. You need to get a manager on your side. And one thing that I like about the managers that I haven't listed here is actually they can give you opportunities. They really, if you have a really good chemistry with your manager, if you have a good chemistry with your coach, their job is to make your opportunities. Just like I'm also one of the coach, I give opportunities to people, even to people that are not working for ING, that I used to work, for example, in Middle East. They still come to me and say, "Hey, can you be my reference, or can you tell me how I should go into my career next?" So if you want to be great, you must have a coach. You must have someone who can give you feedback and guide you, and don't be afraid about asking for help. And that's actually better if you have someone who can guide you. So how to spot the right coach? Understand that there's a good chemistry, so you must, hopefully you like each other, and that helps. You need to get a frequent feedback. You're open to critiques, for sure. Hopefully the coach is more experienced than you, and know the domain well, and you treat them as an advisor, not just your boss, right? And they can be highly analytical and attention to detail, so that helps as well. So that's it. That's the 5 tips that I have. I will go to 2 slides, two more topics. The career anti-pattern, so things that I recommend engineers not to do. One of them is called resume-driven development. Resume-driven development is where developer or development team finds a really cool piece of technology and looks for an excuse to use it. Now, this is dangerous. First of all, the intent is wrong and not beneficial to your company. You could end it up jeopardizing company where this becomes a tech problem or debt, right? Worst I've seen is actually startup died because of greenfield, and then they use a lot of exotic technologies, looks cool, but the projects got delayed to 1 year. Now, of course, everybody is trying to use the latest and trendiest technology. I get it. They want to be in that game. But sometimes if it's not the right technology, please don't use it, because that means you don't know your fundamentals. But also the danger part is you got to remember the success. Your resume is not about what you put in terms of technology. Technology change. So by putting Golang or Haskell or event-driven architecture in your resume doesn't make you more appealing. Actually, a lot of people just listed the skills, but what's more important is what do you want to be remembered as? So if you have a choice of putting Haskell versus I built a bank in 9 months, for someone who's hiring, it's building a bank in 9 months is more appealing, and you're actually more proud in terms of your achievements. So in your resume, think about what have you achieved instead of just being a skills junkies. And I've seen a lot of the sad part of it, the resume-driven development. It sometimes kills the industry, because I've seen so many wasted money that it's actually a result of this. The last anti-pattern that I want to talk about is obviously the common job hoppers. Again, job hoppers, the problem with job hopping is people don't realize it takes time to settle for a job. So if you want to learn something, it will actually take time. And I see commonly people just move jobs every 1 year, or even less than that. So you must ask yourself, how do you even learn, or how do you even gain experience? Yes, the perception is you gain more experience, you gain more skills in a faster time, but you're also getting more pays, getting more titles in a short period of time. In theory, that's the truth, but in reality, the truth is you're actually losing your credibility. People will see you as a bit of disloyal, and actually it will hamper your progress to improve, because there is no possible way that you're gonna learn something meaningful in less than, let's say, 9 months. You're spending most of the time in probations, than actually making your marks to be what you want to be remembered as. So that's the two career anti-pattern for me, that if you want to improve, don't do RDD and don't job hops. Be patient. It takes time. Remember, experts are made, not born. So don't take shortcuts. Thank you very much. So I'm okay now for questions. Thanks for tuning in.